Mars after Earth is considered the planet with the best conditions to permanently host humanity. Various agencies such as SpaceX and NASA have been working tirelessly to take the next generation of explorers to the red planet. However, this extraordinary achievement has not yet been reached due to a number of technical, financial, and logistical factors. Still, many wonder, would you be willing to embark on a one-way trip to Mars and, in a way, become an extraterrestrial far from the home we know? To date, one of humanity's greatest feats was reaching the moon during the space race in the 1960s. During that period, NASA successfully sent 6 crewed missions to the lunar surface, allowing 12 astronauts to set foot on our natural satellite. Some still doubt this achievement, but it was well documented and the result of immense scientific and technological effort. Over the decades, we have grown accustomed to seeing astronauts on what almost seem like routine missions to the International Space Station, where they can spend weeks or even months. This leads some people to believe that, with technological advances, sending humans to Mars would be relatively simple today. Yet even looking at the near future, getting the first humans to the red planet is still a very distant goal. Current science and technology point out that the biggest obstacle is the gigantic distance. For journeys to the International Space Station or to other bases in low Earth orbit, such as China's Tiangong, the altitudes involved are about 250 miles. This region, where spacecraft usually orbit Earth, is called low Earth orbit, LEO. Lunar missions go far beyond that, since the moon is about 236,000 miles away from our planet, and during the Apollo missions, the trip lasted around 3 days. When the destination is Mars, however, the situation becomes considerably more complex because it is necessary to leave a geocentric orbit and enter a heliocentric orbit around the Sun, which completely changes the order of magnitude of the distances involved. The closest distance between Earth and Mars, under ideal alignment conditions, is approximately 34,175,000 miles. But this only happens every 26 months, during a few weeks known as the approach window. Outside of this period, the separation can reach hundreds of millions of miles. In comparison with the Earth-Moon distance, Mars' maximum distance can be 1,000 times greater. And if we consider just the low orbits where humans routinely travel, the difference is on the order of 1,000,000 times. These numbers alone give an idea of the challenge it would be to keep humans safe during such a long and dangerous journey. To put it in perspective, just compare the space missions we have dealt with in history. In the 1960s, NASA's Mercury program managed to get astronaut John Glenn into Earth orbit on the Mercury 6 mission. A 29-meter-tall, 120-ton Atlas rocket was able to launch about 1.2 tons to roughly 124 miles above Earth, and the flight lasted just over 5 hours. Jumping to the trips to the Moon, Apollo 17, the last crewed mission to our natural satellite, relied on the gigantic Saturn V, over 110 meters tall and more than 3,000 tons, to place about 50 tons in lunar orbit. 3 astronauts were sent on a mission lasting 12.5 days, with 2 of them walking on the lunar surface for around 3 days, while the third stayed in orbit waiting for their return. Now, when it comes to a trip to Mars, the idea is for the crew to consist of 6 people, as a larger group makes managing research tasks, maintenance, and mutual care more feasible. Considering a possible window in 2037, the trip there could take up to 174 days, and the return 201 days, with a stay of 539 days on Martian soil while waiting for another favorable planetary alignment. Altogether, the mission could last almost 914 days. That is, nearly 2.5 years away from home. This extended period on Mars, although it may seem exaggerated, is necessary to save fuel and supplies, since it would be impractical to launch multiple shipments constantly to keep the crew fully equipped. Even this becomes a colossal logistical problem, as hundreds or even thousands of tons of cargo would have to be planned and transported. These facts explain why sending humans to Mars continues to be one of the greatest frontiers of space exploration. Even though we have landed on the Moon several times and see astronauts going to the ISS quite frequently, covering this enormous distance and sustaining 6 people for such a long period goes far beyond what has been done so far. And this is without mentioning important details like the effects of space radiation, the impact of a microgravity environment on the human body, the reliability of life support systems, and countless other points that need to be carefully and precisely addressed. It is an audacious and monumental step, but at the same time, it is fascinating for all those who dream of expanding humanity's horizons and maybe one day calling the red planet home. As it is clear, the difference between reaching the moon and getting to Mars is gigantic. It is not just a matter of doubling the crew size, but also of facing a mission that lasts about 73 times longer than the longest lunar mission, which would require roughly 150 times more supplies. This additional time in an interplanetary journey also calls for much more elaborate protection against space radiation, which generally means adding even more mass to the spacecraft. And this is a problem that has not yet been fully solved. Another major concern is the durability of equipment over months or even years of travel. When something wears out on the International Space Station, it is usually possible to send spare parts on board cargo vessels. But on a mission to Mars, anything that might fail must be repaired on site or replaced with backup components that were brought along from the start. That, in itself, requires a considerable increase in weight and volume. Sending such an enormous mass to Mars also implies carrying more fuel, not only to accelerate the spacecraft during departure, but also to slow it down upon arriving at the red planet. And then there's the fuel needed for the return to Earth, which totals hundreds of tons. Some scientists consider using minerals and gases found in the Martian subsurface to produce fuel locally, but so far there isn't a tested and approved system that can do this in a viable way. As a result, we remain dependent on carrying our own propellant. The estimates suggest that a mission to Mars might require between 850 and 1,250 tons of fuel in total, which is an astronomical amount, considering that the entire International Space Station weighs around 420 tons. To put 15 to 25 tons into low Earth orbit, the space shuttle was used. The Ariane 5, or the Russian Proton rocket, can carry roughly up to 20 tons. In other words, transporting something on the order of hundreds of tons to Mars would have to be done over several trips. One single rocket wouldn't be enough for all the propulsion modules, fuel tanks, habitat, and other necessary equipment, requiring multiple launches, perhaps around 10, from vehicles as powerful as the Saturn V or even more, in order to assemble everything in space and send the crew last. This is pretty much the plan Elon Musk has with the most powerful rocket ever built, SpaceX's Starship. It is worth mentioning that during the entire Apollo program, fewer than 20 Saturn V rockets were used. This enormous 110-meter-tall, 3,000-ton rocket was designed specifically to go to the moon, managing to place just over 120 tons in low Earth orbit and about 50 tons toward our natural satellite. It still holds the title of the most powerful launcher ever operated, and only the SLS and Starship have the potential to surpass or at least match its performance. Another delicate issue is the absence of gravity during long flights. Spending 539 days in microgravity, which would be necessary for most of the journey, deeply affects the human body, especially if the person only has a few days to adjust before landing on a planet where, if health problems occur, no help is available aside from the crew. For now, we don't have those spacious rotating ships from the movies that simulate gravity through acceleration. Therefore, astronauts going to Mars would be subject to the effects of zero gravity throughout the trip, and no one is quite sure how they would recover upon arrival. Once on Mars, other setbacks arise, such as living confined almost all the time in cabins that might be as small or even smaller than the transport spacecraft, since the suits for exploring the surface have a limited usage time. Although there are optimistic voices who argue that current technology would already allow such an adventure, scientific data shows that many challenges still lie ahead. Nothing is impossible, but an enormous investment of resources and time would be needed to prepare all the details. NASA believes that with modern science and technologies, we could land the first humans on Mars before the end of the next decade. Others think there is still a long way to go, while the most optimistic expect that we might achieve this milestone within the coming years. Considering all the obstacles that could arise during a mission to Mars, it is likely that with today's technology, it would be extremely difficult to arrive safely at the red planet. And even if the landing were successful, the effects of months of exposure to microgravity on the human body could cause serious health issues, making it hard to adapt to Martian gravity. However, it is important to remember that science and engineering are advancing rapidly, developing solutions for challenges such as cosmic radiation, prolonged isolation, and maintaining vital systems. It is through these advances that we can hope that, in a not-too-distant future, someone will finally set foot on Martian soil, and maybe we'll witness that historic moment. What do you think about all this? Do you believe we are close to seeing humans walking on Mars? Or do we still need to solve too many problems for that to happen? Leave your opinion in the comments. Thank you very much for staying with us until the end, and see you next time.